Hi, I'm John Ainsley, CTO at Doulos. In this video, I'm going to be talking about easier UVM configuration. This video is going to be an in-depth tutorial on UVM configurations. In this video, I'm going to be following the easier UVM coding guidelines from Doulos, and I'll also be showing examples that were created using the easier UVM code generator. One of the beauties of this is that you can reproduce and extend these examples for yourselves by downloading and running the free easier UVM code generator that you can find at this URL. So here goes. Let's take an in-depth look at UVM configurations. Configurations in UVM are all about configuring or parameterizing the UVM component hierarchy. And the configuration database is just a database or a repository for storing parameters. These parameters are typically used during the UVM build phase as we build components, but the configuration database can actually be accessed at any time during simulation. In the easier UVM coding guidelines, we recommend that you only set and get parameters in the configuration database during the build phase. And the build phase works top-down, which means that information typically flows top-down through the configuration database. So the top-level module shown here, or a high-level UVM component, can set parameters in the configuration database, and then lower-level components will get those parameters out of the configuration database again. And those parameters can be used to configure anything in the UVM component hierarchy. So vector widths, memory depths, file names, optional features, anything you can think of within the verification environment or test bench can be parameterized through the UVM configuration database. The configuration database itself just contains a set of triplets where each triplet consists of a scope string, a name, and a value for a given parameter. Items are written into the configuration database by calling its set method. And one of the items that's typically written into the configuration database is a virtual interface. The virtual interface allows the class-based UVM verification environment to refer to interfaces in the module-based part of the System Verilog world. So typically a top-level module would set a virtual interface into the configuration database, as we can see here. And one of the features of the configuration database is that it stands apart from both the module hierarchy and the UVM component hierarchy. So we can actually set parameters into the configuration database even if the UVM component hierarchy hasn't been instantiated yet, and that will be exactly the case in the top-level module. Then we'd run our UVM test, and the run test method of UVM would instantiate the entire UVM component hierarchy and run through all the phases. And then the individual UVM components can get parameters back out of the configuration database again. In this particular case, we're storing a virtual interface in the configuration database, so the agent that retrieves the configuration information from the configuration database is assigning virtual interface references within the monitors and drivers. The main methods that we use to access the configuration database are set and get, so let's take a look at those in some detail. You can see that there's a lot of symmetry between set and get. They each have 4 arguments and a data type that's used to parameterize UVM config DB. The type here is the type of the parameter value. So in any call to set or get, the final argument, which is the value of the parameter, will be of the type given as an argument to UVM config DB. Then the first 2 arguments to set identify the scope in the configuration database, and the third argument is a string identifying the name of the parameter. The scope is identified using 2 different arguments, a reference to a component and a relative path name. So you can see here the scope is constructed by concatenating the full name of the caller, that is the component passed as a first argument, then a dot, and then the relative path passed as a second argument. And you in principle, have a degree of flexibility about which part of the path name is implicit within the component reference and which part of the path name you spell out in the relative path name, although there are some very important constraints on that, as we'll see. I'll explain what I mean in a bit more detail as we go on. Although the set and get methods are fairly symmetrical when it comes to their arguments, there's a very strong convention as to how you should call them. So when you call set, the first argument is typically going to be a reference to the calling component, and the second argument is going to be the relative path name of the component whose parameters you're setting. Then when you call get, the first argument is again a reference to the calling component, and the second argument is typically a null string because the component is usually interested in retrieving its own parameters. Through the calls to set and get, there's all sorts of potential for doing weird and wonderful things. So you could make a call to set a parameter in an unrelated part of the component hierarchy, and similarly a call to get could get a parameter that applies to an unrelated part of the component hierarchy. But in the easier UVM coding guidelines, we would regard either of those things as bad practice, and you should normally follow the calling conventions exactly as you see them here. So these set and get calls allow values of any type to be written into the configuration database. Within the easier UVM coding guidelines, we follow a somewhat tighter convention. What we do is to package all of the configuration information for a given agent into a single configuration object. So in easier UVM, each agent has one configuration object, and that's true whether the agent is a standalone agent or whether the agent is instantiated within its own env. Whichever way, that agent has one configuration object. And then the top level env has a configuration object of its own that contains information that's set from the top level module. In particular, the top-level configuration is going to contain virtual interfaces that can only be set from the module-based world in System Verilog. So we're going to be seeing our top-level module setting virtual interfaces into the top-level configuration object, and the top-level env then distributes that information around the configuration objects for the individual agents. Well, by taking advantage of UVM and taking advantage of the easier UVM code generator, we can customize the values in these configuration objects in order to parameterize our agents to do whatever we want them to do. Anyway, on the slides that follow, you're going to see three examples. We're going to start off by setting the top-level configuration into the configuration database from the top-level module. Then we'll see the top-level env getting the configuration object from the configuration database and creating and setting configuration objects for the individual agents. And then finally, we'll see an agent getting its configuration object from the configuration database. And I'm presenting the example in this way because it'll help you to understand the code that comes out of the easier UVM code generator if you want to use the code generator yourself as a way of helping you to learn UVM or even generating the code for your first project. So in easier UVM, we're going to write configuration objects into the configuration database. And here's one of the automatically generated configuration classes. This is the class for our top-level configuration object. Most of this is boilerplate code. In other words, it's exactly the same for every configuration object. A configuration object is just a class that extends UVM object, and then it contains a set of variables representing configuration parameters. So you can see in easier UVM as standard, we have a virtual interface for each agent, and also for each agent we have an isActive flag to say whether that agent is running in active or passive mode. And we have two 1-bit flags, checks enable and coverage enable, to enable checks or coverage respectively. Those flags were actually documented in the standard UVM user guide, and we've borrowed those in the easier UVM coding guidelines. So here's our top-level module as it comes out of the easier UVM code generator. So I'll step through this line by line so we can see what it's doing. The first piece of code I'm showing here is the instance of the test harness. So the test harness top.th is just a System Verilog module that instantiates the design under test and also instantiates any interfaces for the design under test. Then we have a variable that's going to refer to our top-level configuration object. And then within the procedure, we instantiate the configuration object. And then we randomize the configuration object. And the reason for randomizing the configuration object is that we might have inserted some user-defined rand variables into our configuration class. Going back to the previous slide, this is the code that comes straight out of the code generator, but if we wish, using the code generator's template files, we can insert user-defined code fragments here. So by using the setting config var, for example, we could insert user-defined configuration variables into our config objects. And if one of those config variables happens to be a randomized variable, then here you can see there would be some real purpose to randomizing the configuration object. So here in the top-level module, we're initializing all of those variables. In particular, we're setting the virtual interface in the configuration object to refer to the actual interface instance within our test harness. And we're also setting default values for the remaining parameters in the configuration object. Then we're calling set to set that configuration object into the configuration database. The first argument, the caller, is set to null. The first argument is always a reference to the calling component. But if we're calling set from a top-level module, then of course there is no calling component. That's particularly pertinent because we're calling set before calling run test. And in UVM, it's the run test method that actually runs all of the UVM phases. So the UVM component hierarchy is only created when run test is called. When we're setting this first parameter into the configuration database, there is no UVM component hierarchy, but we can call set nonetheless. The caller is null, and then the second argument is a string, which is specifying as a string the path to the particular UVM component, the top-level env in this case. We then have a name for the configuration parameter and the value of the configuration parameter, which is just the reference to the configuration object. Now let's jump to the top-level env, and in particular to the build phase method. So as I've said already, we typically set and get values in the configuration database during the build phase top-down. So the top-level module gets the first chance to set values in the configuration database. Then here in the build phase of the top-level environment, we're getting the configuration object that was set from the top-level module. And if get is unable to get the parameter of the given type and name and scope, then it will return false. And in this case, we're printing out an error message. Then in the top-level env, we're going to create configuration objects for each of the agents. In this case, we're creating a configuration object for the clock and data agent. And then we're copying the relevant parameters from the top-level configuration object into the configuration objects for all of the individual agents. In this particular example, we've only got a single agent, so there's only one agent's configuration object to create and set up. But if you run the code generator with a number of agents, then you're going to see multiple lower-level configuration objects being created here. Again, most of this is boilerplate code, apart from the code in blue that refers to the actual name of the agent. And you can also see comments here showing you where you can insert your own code fragments by using the appropriate settings within the code generator interface template files. So if you wanted to copy the values of user-defined configuration parameters from the top-level configuration object down into the configuration object for a particular agent, you would use the setting agent copy config vars in the interface template file of the corresponding agent. Then we're setting the configuration object for each agent within the configuration database. And we're also setting the same configuration object with the scope set to the sequencer of the agent. And that allows sequences, user-defined sequences running on our sequencer, to retrieve parameters from that same configuration object, which is a very handy trick. Let's just review the first two parameters to set and get once more. So the first parameter is of type UVM component. It's either a reference to a UVM component or null if there is no appropriate UVM component. So the recommended guideline is if you're calling set from a System Verilog module, you should set the first argument to null and the second argument to the absolute path name of the UVM component whose parameter you're setting. If you're calling set from another UVM component, then the first argument should always be this, that is a reference to the calling object, and the second argument will then be a relative path name. And the scope is going to be determined by concatenating the full name of the caller with this relative path name. It is possible to abuse these arguments, or perhaps I should say use them differently. So we could make a call from a UVM component, set the first argument to null, and then specify an absolute path name. And the scope in the UVM configuration database would still be set correctly. However, it might not have the behaviour you want. There are some subtleties of the UVM configuration database that I'm going to describe later on in this video that mean that you really want to stick to the convention shown here. And in fact, the easier UVM coding guidelines are quite definite about it. Always use null when you're calling set from a System Verilog module. Always set the first argument to this when you're calling set from another UVM component. Now we'll step down to the bottom of the UVM component hierarchy and look at an individual agent retrieving its configuration object. So here in the build phase method of our clock and data agent, we're getting the configuration object for the clock and data agent, and once more printing out an error message if it didn't happen to exist. That configuration object, if you remember, contains a virtual interface, and it also contains a flag to say whether the agent is being run in active or passive mode. In the easier UVM coding guidelines, what we do is to override the getIsActive method, which is permitted by the letter of the UVM standard, and we override that method in order to retrieve that flag from the corresponding config object. So here within getIsActive, you can see we're pulling out the isActive field of mconfig. That was a reference to the config object from the configuration database, and we're using that flag as the value returned from getIsActive, which determines whether or not we're instantiating the sequencer and the driver. We now step on to the connect phase method of that same agent. The connect phase is making use of the virtual interface. First of all, we've got some defensive programming to check that that virtual interface was actually properly set within the configuration object. And assuming it was set, we're assigning the virtual interface variables within the monitor and driver components to refer to the System Verilog interface. So we're copying the virtual interface from the configuration object into our monitor and driver components. There's one final step that you might be interested in. So far, we've set the top-level configuration object, set the lower-level configuration objects, and then retrieved information from those configuration objects. But all the configuration information was set up by default from the top-level module. What happens when we want to change the configuration parameters? Well, the answer is that we can do that from our test by retrieving and then modifying the configuration object. That's what we do in easier UVM. In particular, that's what the code from the easier UVM code generator allows you to do. So let's take a look at that. So here's the top-level test. Most of this, as usual, is boilerplate code that just comes out of the code generator. So a test always extends UVM test. We've then got a variable menv that is a reference to our top-level environment, and boilerplate code declaring the constructor and the build phase method. Then within the build phase method, we've taken advantage of a setting within the UVM code generator template file to prepend some code to the build phase method. So the text shown in blue here is a user-defined code fragment that's been sucked in and inlined within the automatically generated code. And what this code fragment is doing is getting the top-level configuration object from the configuration database and then modifying one of those configuration parameters. In this case, we're setting the coverage enable flag of the clock and data agent to 0 to disable coverage collection for a particular component. And you could modify any configuration parameters, including configuration parameters predefined by easier UVM, or indeed user-defined configuration parameters, using this same mechanism. Now, in the final part of this video, I'm going to dive into some of the subtleties of the UVM configuration database and really help you to understand what's going on if you choose to be a bit more adventurous. Let's consider firstly what happens if you set the same parameter into the configuration database multiple times. So the key point here is that we're making multiple calls to set for the same configuration parameter where the names and the scopes are also the same for each call. So in each case the data type is T, the scope is this M agent, and the name of the parameter is name, but on each call we're choosing a different value. If you make multiple calls to set from the same function, from the same scope, then what's going to happen is that each call will simply overwrite the previous call in effect. So after the first call to set, name is value 1. After the second call, that value's been overwritten by value 2. After the third call, that value's been overwritten by value 3. So that's what's going to happen in general if you make multiple calls to set. What happens simply is that the last call wins. However, there's one very important special case, and that special case is characteristic, almost definitive, of the UVM configuration database. The special case is what happens if you set the same parameter from multiple levels of the UVM component hierarchy during the build phase. Here's such an example. So here we're setting a parameter named param to 3 different values, value 1, value 2, value 3, from 3 different levels in the UVM component hierarchy. So the top level module, top TB, sets param to value 1. Our test then sets param to value 2. And our env sets param to value 3. And then down within an agent, we get the value of param. And the question is, of course, what value are we going to get? Value 1, value 2, or value 3? Now note that in each case here, the name of the parameter is the same, the type of the parameter is the same, and the scope is the same. The scope is the agent in each case. And if type, scope and name all match, then a very particular rule comes into play that involves the way that get searches multiple definitions in the UVM configuration database. And to cut to the chase, the winner is actually going to be value 1. Why value 1? Well, the rationale is that if you set values into the configuration database from lower level components, they effectively act as defaults. So when we instantiate top env, the value of param is going to have the value 3. But we could then override that value from a particular test. So top test actually overwrites value 3 with value 2. And then we get a final chance to override that parameter from the top level module. Now, we're showing these 3 cases for technical completeness. In practice, you're unlikely to want to override a parameter like this from the top level module. What you would probably do is to set up default values for your parameters within agents or envs, and then override the value of the parameter with a different value from a particular test. But if you were to call set again from the same parameter from the top level module, that would actually be the winner. So this is a very important special case, and it's very important that you understand it carefully if you're going to try to make multiple calls to set for the same configuration parameter. Incidentally, this is also the reason why it's so important to get the first argument to set right, because the search order here, where we've set the same parameter multiple times, is determined by the component hierarchy, and the UVM configuration database gets its knowledge of the UVM component hierarchy from the first argument to set. So value 1 is the winner because this is the call that's been made with the first argument set to null. Now another subtlety of the UVM configuration database. The idea of the UVM configuration database is that the scope, as defined by the first two arguments, corresponds to the UVM component name within the UVM component hierarchy. But it doesn't have to. The path names that you use within calls to set and get can be a sham. They can refer to a mythical UVM component hierarchy that doesn't actually exist, and that can have uses. So here, for example, we've set up a bucket to store values within the configuration database that's totally unrelated to the name of any actual UVM component. So we've written param1, param2 and param3 of types t1, t2 and t3 into our value bucket in the configuration database. And we can then get param2 out of the value bucket again, just as if value bucket was the name of an actual UVM component. It isn't. It's a name that we just made up in the calls to set and get. So you can use the UVM configuration database as a repository for parameters, even if those parameters are not associated with specific UVM components. Another subtlety is that we can use wildcards within the scope string that's sent to set. So in this case, when we write param2, we've set the scope to value.star, and param3 has got its scope set to star. And star, within a string in UVM, in a number of contexts, is a wildcard, technically known as globbing. So in a glob, a star refers to 0 or more characters, any characters. So when we make the call here to retrieve param2, from value.bucket, that call is going to succeed because the scope value.bucket would match the wildcarded string value.star. So value would get set to value 2. In the bottom line, when we try to retrieve param3 from Neverland, that call to get is going to match as well because Neverland is going to match our wildcard scope star made when we set the param3 into the configuration database. So when you're setting parameters in the configuration database in UVM, you can set parameters to apply simultaneously to more than one component, or indeed to every component in the UVM component hierarchy. The only thing to be a little careful about is there can be a performance hit to using wildcards. That's one reason for only calling set and get during the build phase, because even if there is a performance hit involved in matching wildcarded scopes, if you only call set and get during the build phase, that performance hit isn't going to affect you too much in terms of simulation time. Finally, there's a couple of utilities that you can use for debug. UVM component has a print config method, and print config prints out all of the configuration settings that apply to that specific component in the configuration database. There's a couple of flags that you can pass to arguments. If you set the recurse bit to 1, that recursively prints out the same information for all of the children of the given component. And if you set the audit bit to 1, then it prints out an audit trail of all the calls to set and get for each component. That's quite verbose, but it can be useful for debug. Then there's another method, checkConfig usage, which is intended to help catch a very specific pitfall. It's quite easy to make typos when you're calling set and get. And if you do accidentally mistype some of the names, it's possible to simply have mismatches when you're trying to set and get the same parameter. And that's where checkConfig usage is useful, because checkConfig usage prints out cases where there have been calls to set with no corresponding call to get. So if you make a typo in your parameter name or your scope name, that's going to get caught by calling checkConfig usage. So I've given you a fairly comprehensive tutorial on the basic operation of the UVM configuration database, and also spelt out some of the rules that we recommend in the Easier UVM coding guidelines. You can now download the coding guidelines in the code generator for yourselves and reproduce all of these examples and try playing with them. So I hope you've benefited from this video. At Doulos, we're a training company and we'd love to sell you a training class. We deliver training all the way around the world in hardware design and verification, SystemC and system modelling, embedded systems, and in ARM processor technology. If you want to know any more, go onto our website www.doulos.com where you can read a lot more details.